Good morning, my name is Alexander. I'm going to talk about a job that I did in the graduation course together with an advisor professor. Approximation in physics. I study section of the simple pendulum. Objectives. Discuss the use of approximation in the study of the pendulum, sin theta, approximately theta. Starting from the empirical in search of an empirical equation able to predict the period of oscillation of the simple pendulum for a given length. Show experimentally that the use of approximation in the study section of the simple pendulum is not a logical crime, but a way to facilitate the understanding of your study. Experiment. A simple pendulum supported by the supported fixed to the wall, a nylon thread with a metallic mass on end. The system is controlled at a distance by an electromagnet. Data collect. To collect the system data, I chose the tracker. I do video analysis frame by frame. Just insert a video of the system in motion. Add a single measure. Uh, in this case, I used the length of the wire. Mark a point of mass for analysis in the center of the ball and start the movement. The system provides measurement of oscillation, time, amplitude, plot a graph with the movement, amplitude versus time. Results. This table shows the first 10 periods measured, varying the amplitude and keeping a fixed length. The idea would be to have an approximate quantification of the amplitude in which the pendulum period escapes the margin of error of the experiment itself. We can see that the biggest disturbance starts to occur when the amplitude becomes greater than 8 degrees. To show that the experiment had a minimal influence caused by the retarding force, we calculated the energy variation from the first period to the last one, when realized that is less that they were associated with the experiment. Then we perform more measurement, keeping a fixed amplitude and varying the length from 10 centimeters to 1 meter, but to get a period for each length. The software automatically adjusts a curve to, to the measured points containing the following results, which the length and period data. We arrive by trial and error to an equation that relates the two results in the constant. So we have the expression for the period depending only on the length. Using the basis theory, we know to test this equation. We start from Newton's second law for rotations and using the approximation sin theta approximately theta, considering that the movement occurs in Earth surface, we can describe the pendulum movement by a simple harmonic oscillator. And using the right conditions, we have the period equation. Relating the two equations, we can see that the empirical constant is now related to the gravitational acceleration constant, g. So we have not concluded any absurd. And we can say that the approximation using the study of the pendulum is valid, while the obtaining constant, when dealing with small minor oscillation for equal to 10 degrees. Conclusion. Inside the limitations of the study, it was possible to describe the period only according to 10 pendulum length. The approximation sin theta approximately theta is satisfactory inside its limits of use for small amplitudes. We can consider this word as way to facilitate the approximation of recurring problems in physics as a simple pendulum. Thanks.
Great, thank you.